All right, people, this is 2.1/2.2 notes, beginning of chapter 2. You've been doing a couple of explorations looking at quadratics. Now, remember, quadratic, slightly different than what we've been doing because we've been doing linear and absolute value stuff, but quadratic was that other one, and we talked about how you know it's quadratic because it's got a highest power of 2. So for instance, number 1 here, you can tell, well, it's not absolute value because there's no absolute value bars, duh, but it's also not linear because it's got this exponent of 2. And we're going to graph it. Now, last week you looked at an exploration on vertex form. X minus h squared plus k. Now this should look incredibly familiar because it's extremely similar to what we did with absolute value. And even some of the different pieces. For instance, you found out that this number on the inside is going to move your graph left and right. This number all the way at the end is going to move your graph up or down. And then this number right here is going to do that stretch/shrink, where it makes it wider or skinnier. And then if there's a negative in front, that'll flip it down. All that stuff is still the same. So let's look at an example and see how this would work. Now the vertex, just like we did with absolute value, is always the opposite of the inside, comma the outside. The opposite of the inside is a positive 1, comma the outside is a positive 2. So my vertex here would be 1, comma 2. So I'm going to put that on my graph here, 1, comma 2, put a dot. Okay. Now, with absolute value, what we did next is we looked at whatever number was in front here, and since there isn't a number, we can always add a 1. And we looked at that as the slope of our right-hand side. In this case, 1 over 1. Meaning I go up 1, right 1. And then I'd mirror image on the other side, up 1, left 1. Now, when we did this with absolute values, all you would do is you draw 2 straight lines. Well, that's no longer the case. It's no longer a straight line. It's actually a curved U now. I am not going to get too picky about how beautiful your quadratic graphs look. I know mine is gorgeous and it's okay to be jealous, but you've got this U shape going on. This U shape has a name. The name of this U shape is a parabola. You should have found that out in your exploration. Now, parabola literally is just the name of the shape. So we'll say a U all the time, but it's technically not a U, it's a parabola. Okay? All right, now there's a couple other pieces here. AOS, and then is the vertex a maximum or a minimum? So let's talk about that for a second. AOS stands for axis of symmetry. Spelled that wrong. I think there's 2 M's there. Yeah, axis of symmetry. And that's talking about this line that goes straight down the center. Something like that, right? It cuts your parabola in half, perfectly in half, I might add, meaning the left-hand side should be a beautiful mirror image of the right-hand side. So now when I ask you for the axis of symmetry, you need to tell me what is the equation of that line. Now it's way simpler than it seems at first. So the equation of a line that's straight up and down always starts with x equals. And then you just need to look at the x value here, which looks like is 1. Now here's a simpler way of doing this. The axis of symmetry is always going to be the x value of the vertex. That's it. So if the x value is 1, the axis of symmetry is x equals 1. Done. And lastly, is the vertex a max or a min? Another way of thinking about this is a top or a bottom. So like if I look at this parabola and I look at the vertex, is the vertex at the very top of the parabola or is the vertex at the very bottom? Now, hopefully you'll say, oh, that's at the very bottom. So that means it is a minimum. Simple enough. Okay, let's keep going. Number 2. Now I have y equals 2 times x minus 2 squared plus 5. Okay. So we're going to start with my vertex. Again, it's the opposite of the inside, comma, the outside. So 2, comma 5. 1, 2, 3, 4, 5. Good? If you want right now, you can tell me axis of symmetry is x equals, well, the x part of the vertex, so that's 2. Nice. You also could wait until later to do that if you want. Then I'm going to look at this number in front, and that's going to tell me the slope of the right-hand side. So it looks like up 2, right 1. And then remember, this is the axis of symmetry right here. And that's how I know that this is going to be mirror imaged on the other side, because my left side and my right side should be perfectly symmetrical. And remember, I'm not going to make straight lines anymore. I'm going to kind of make a U, aka a parabola. And I asked the same question as before. Is the vertex a max or a min? You should look at this and you should say that's at the bottom again, so it is a minimum. Nothing too crazy, right? All right, let's look at number 3. Slightly different because it's got a negative in front. We'll see how that changes things. My vertex still the opposite of the inside. Stay consistent in my colors. So the inside is a positive 7, so the opposite would be a negative 7, comma the outside, which is a negative 8. Right now I can say the axis of symmetry is going to be at negative 7. X equals negative 7. That's going to be this line right here. Now it doesn't actually ask you to draw the axis of symmetry, so you don't have to if you don't want to. I just kind of like to. I'm going to put my vertex negative 7, comma, negative 8. So I go negative 7 all the way down to negative 8. There's my vertex. Now, I could ask this question. I could say, based on this, is my parabola going to be flipped up or flipped down? And you all should be able to tell me that it's going to be flipped down because of this negative. Another way of thinking about it is negative 3 over 1 is the slope of the right-hand side. So I go down 3 to the right 1, and then I mirror image on the other side, and you can see that it's flipped down. This time, my vertex is at the top of my parabola, so I would call it max. Okay, number 4. Just for fun, if you think you're getting the hang of this at any point, you can pause this and try it yourself. See what you got. Check your skills. Okay. And then you can unpause it and see if you're right. All right, so number 4, opposite of the inside, comma the outside. So the inside is a negative 5, therefore the opposite would be positive. The outside is a negative 3, so opposite of the inside, comma the outside. My axis of symmetry is going to be x part of the vertex. Now, I could actually answer this right now already. Is it a max or a min? Well, since the front here is positive, I know that this parabola is going to be flipped up. I have no idea exactly what it's going to look like, but I know it's going to be flipped up. And therefore, since it's flipped up, I know that the vertex is going to be a minimum. All right, let's graph it. 5, comma, negative 3, my vertex. 1, 2, 3, 4, 5. 1, 2, 3. Good. Now, in front, I've got 1 over 1. I should do this in red. Perfect. So, up 1, right 1. Mirror image it on the other side. Now, sometimes people will only get 3 different points, and that's fine. Like, you could draw your graph from this, but sometimes people want more than just 3 points, and I'm totally fine with that too. Okay, so let me show you if you wanted to find a 4th and a 5th point. Here's what I would do. All right, so the x value of my vertex is 5. Now the x value of this one and this one is a 1 on either side, so 4 and 6. So if I went one more over, 5, 4, 3, what if I plugged in 3 as an x value, and then I saw what I got for y. So let me show you what I mean. I'm going to take y equals x minus 5 squared minus 3, and I'm going to plug in 3. I'm plugging in this x value. My goal is to find a point, 3 comma something, right? So I'm going to plug in 3 and see what comes up. So 3 minus 5 is negative 2. Negative 2 squared is 4. And 4 minus 3 is 1. It means I just found a point, 3 comma 1. And I could graph it. 1, 2, 3, comma 1. And then I could mirror image that over my axis of symmetry. And you can see that that makes it a little bit easier to draw my U because I have more than just these 3 points that are all really, really close together. So this is going to be super helpful. We're actually going to use this a ton. It's saying if I want another point, pick an x value, plug it in, you'll get a y value, and that gives you a point. All right, flip it over. A few more. Okay, number 5. So vertex, opposite of the inside, comma the outside. Opposite of a negative 1 is a positive 1, comma 4. So I know my axis of symmetry is 1. Now, since this is a negative in front, I know it's going to be flipped down. Therefore, I am going to have a maximum. Okay. Now, let's graph it. 1 comma 4 is my vertex. So I'm going to plot that. And then I have my number in front is a negative 1 over 1. So down 1, right 1, and I mirror image it on the other side. Okay. Now, I want to do the same thing we did on the last problem to get another point. So I'm going to look at x values again. Now, you can pick any x value you want, but I'm going to try and keep my numbers as small as possible. The x value of the vertex is 1, so it's not going to be helpful to plug in 1. I'll just get 4. I already know the x value for this point is 2, so why don't we go over one more again and use 3. Which ironically is the same thing that we used last time, but sure, 3. So negative x minus 1 squared plus 4. So negative 3 minus 1 squared plus 4. Again, I'm plugging in 3, and I'm hoping to find, I will find, a y value here. All right, so let's see what we come up with. 3 minus 1 is 2. 2 squared is 4. And then that negative just tacks itself on, so it's a negative 4. Negative 4 plus 4 is 0. So that's the point, 3 comma 0. And then I'm going to look at my axis of symmetry, and I'm going to mirror image it on the other side. 1, 2, 1, 2. Hey, look at that. Now I have 5 points instead of 3. I could do that again if I wanted to. I could find another x value and plug it in to find another y value, but I don't think we need to. And there we go. All right, last one that looks like this. All right, vertex, opposite of the inside, comma the outside. Well, shoot dang, there is no outside. Well, there is. You just have to squint, kind of tilt your head, write it in. Remember the fact that if there is no number, you can always, always, always add a 0. Axis of symmetry is the x value of the vertex. Now, since this is positive in front, I know it's going to be flipped up. Therefore, my vertex is going to be at the bottom, aka a minimum. Now, let's graph it. So I'm going to graph my vertex of negative 1 comma 0. And then I've got 2 over 1 is this thing in front. Gives me the slope of the right-hand side, so up 2, right 1. Mirror image on the other side. And I've got these 3 points. But let's find one more. Okay. Now I'm going to look at the x values of these 3 things. X value here would be negative 1 for the vertex, and then negative 2 and 0. Those are the x values of these 2 points. So what I typically do is I just find one more point on either side. It doesn't really matter which way you go. I tend to look at positives, so let's look at x value of positive 1. So 2 times x plus 1 squared. You don't need the plus 0 anymore, although you can put it. And then we're plugging in 1. So then I can see what y value I get. So 2 times 1 plus 1 is 2 squared. 2 squared is 4, and 2 times 4 is 8. So that is 1 comma 8. So 1 comma 1, 2, 3, 4, 5, 6, 7, 8, all the way at the top there. And then we're going to mirror image that on the other side. Again, if you need to draw the axis of symmetry here, that's 2 spaces away from the axis of symmetry. So you go 2 spaces on the other side, connect them, draw your U. Again, it does not have to be pretty. Good to go. So that's how you graph something in vertex form. Now, these last 3 down here, I'm actually asking you to write the equation in vertex form given the graph. It's kind of the opposite. It's not nearly as bad as it looks. You only need 2 things. You need the vertex, and then you need that slope of the right-hand side, remember? So I'm going to look at my vertex here. Y equals x squared. So remember, the x part of your vertex goes here, and the y part goes here. So the vertex, it looks like the coordinates of this point is -1 comma -2. So don't forget that the x value, the opposite of the x value, goes on the inside, so we'd put a +1, and then the y value goes on the outside. Now you're going to find your next point over, and then tell me what is the slope? Up 1 over 1. So you could put 1 over 1 if you want, but you don't even really need to, because that's just a 1. Multiplying by 1 does nothing. All right, let's look at 8. So same thing, y equals, you're just filling in your little bits of missing information. Vertex this time looks like it's 2 comma 7. So opposite of the x value goes here, and then the y value goes here. And then I'm going to look at the next point on the right-hand side. And it looks like my slope here is I go down 2, right 1. So -2 over 1, or just -2. And I'm cool with writing it as -2 over 1. And that's it. Number 9, last one. Y equals, okay, so it looks like my vertex is at 2 comma 0. So opposite of the x value goes on the inside, right? And then the y value goes on the outside, but I'm not going to write +0 because I don't actually need that. If you want to write +0, you can, but it's not going to be helpful at all. And I look at one more point on the right-hand side, up 1 over 1. So again, if you wanted to put 1 over 1 here, you could, but you don't need to because that's just a 1. All right, that's it.